Hello everyone, welcome back to our channel. Now in this video we are going to implement the algorithm that is going to tell you if your graph has a cycle or not. So you remember in last video we implemented this topological sort which only works on the graph which don't have cycle. But how do you check if your graph even has a cycle or not, right? For that we are going to use a concept of three different sections which is going to contain all the nodes of the graph, which is then you're going to visit them one by one. So we need one set where you can keep track of visiting nodes, and in third section you're going to keep track of nodes which you already visited. So that is the logic that we are going to use here to implement, to check if your graph has cycle or not. So let's go ahead and implement this. It is going to return a boolean value. First thing that you need here is those three sections, that is collection of all nodes, collection of visiting nodes, and collection of already visited nodes. So all three are going to be set in our case. So let's create those, and this is going to contain all our nodes. Now you need those two other collections as well. Now according to algorithm you need to keep iterating till this all nodes, this collection becomes empty. So while all dot is not empty, you're supposed to loop through. And what you're supposed to loop, you can take any of the node from the all collection. Basically you have a set of graph node, right, which you are naming all. So from this you are going to take any random node. So to pick the first available value, you have a way of getting it from iterator from next. Okay, so on this current node what you're supposed to do, you're going to check from that particular node, you're going to traverse, and then you're going to check if that node has cycle or not. How, that we'll check later. But if you have a cycle from this node, right, which is going to take your current node and it is going to take all those sets, which is all visiting and visited. And if from that particular node when you're iterating, if it has cycle, you are returning true there itself. Perfect. And if you're not able to find any cycle, then you're returning false. This is going to be the implementation of your hash cycle, which you're going to call from main method. What you're doing, you have all those collections, all visiting and visited, and till this all collection this becomes empty, you are picking the node, picking the next available node, and you're performing this hash cycle method, which is going to be a recursive method, and you're checking if there is a cycle from that node or not. If there is a cycle, it will return true, or you're going to return false. Now let's implement this recursive method. Let's make this one public, and this is internal implementation, so let's keep it private. Okay, hash cycle, current node, all looks good. So when you're doing the iterative call, right, first you're supposed to remove that from all collection. All collection means basically this all set that we have created, right? Remove this current node, and when you're removing anything from all, you're supposed to add it to visiting. Visiting dot add this current node. Now you are supposed to iterate for each of the neighbor from this adjacency list dot get current node. This is going to return all the neighbors from that current node, and you're going to iterate, and you're going to check if you have already visited that neighbor or not. So if visited dot contains that particular neighbor, so I have written while by mistake here. Let's convert it to a for. So for each of the neighbor that you are going to get from the current node, what you're supposed to check, if you already visited that neighbor, then you're just supposed to continue with the next iteration. If the neighbor that you're visiting, right, is already part of the visiting collection, that means you're visiting that node currently right now. That means, and this is the point when you know that there is a cycle in your graph or not, is visiting dot contains this particular neighbor. Now if this condition is true, then you can return true directly from here. That that means your graph has a cycle, and that's why you're returning true. If both of these conditions become false, then you're supposed to call your hash cycle method again on that particular neighbor, and you should continue checking for cycle. How you can check? You have passed the neighbor, you have passed all collection, you have passed the visiting set, and you have passed the visited set as well. If this method returns true, then you can return true there itself, telling that your graph has a cycle. If this does not return true for that particular neighbor, right, recursively, what you're supposed to do, so initially what you did, you have removed it from all collection and you have added it to a visiting. Now once you are done checking for its neighbor, right, you are supposed to remove that particular node from visiting, and you're supposed to add that particular node to visited. Perfect. Now once you have done performing these two operations, you can return false. Why you're returning false? Because if there was a cycle, it would have been caught here itself, right? If you came till this point, that's why you are removing it from the visiting collection and adding it to a visited collection, and then you're returning false. So this is how you check if your graph has a cycle or not. So let's try running our code and check if our graph has a cycle. So from the input you can see we have three nodes, A, B and C. A is connected to B, is connected to C, and C is connected to A. So according to our input there is a cycle and you're supposed to get true. This method is supposed to return true, and we are getting true, which is telling yes, your graph has a cycle. Now let's try commenting this last edge. Now that cycle link is gone, now you're supposed to get false, and you're getting false. So the implementation that you have done for hash cycle, it is working perfectly fine. So basically this whole logic depends on those three collection set, which is all, visiting and visited. Okay, so you just have to remember that concept if you want to implement this algorithm. So yes, graph has a lot more other applications as well, which we are going to explore later. Okay, but as part of this video, that's all we are going to explore. See you in the next one.